Now we move ahead to see how to get the equation of pair of tangents to the parabola from some external point. Okay, so let's consider that some parabola is given to us, say standard parabola y square equal to 4ax, and some external point P with the coordinates say x1, y1 is given to us. Now we can see that from any external point we can always draw two distinct tangents to the given parabola. So here we consider that pair of tangents. Now this pair forms a pair of straight lines. So if you have studied the pair of straight lines topic, so in that the joint equation of a pair of lines is to be considered. So this is where that pair of tangents come into picture. So their joint equation is given by the formula S1 is equal to t square. Okay, this is a cryptic formula with the symbols S, S1 and T, and we have to clearly understand what these means. First of all, the symbol S stands for the equation of the curve to which the tangents are drawn. Right? So in our case the curve is a parabola. So we have to write the equation of the parabola in the form in which all the terms are taken on one side and 0 is on right side. Right? So if we are given the curve y square is equal to 4ax, then we have to first write that as y square minus 4ax is equal to 0. In that case, this left hand side expression y square minus 4ax corresponds to the expression s or the symbol s. Right? Now when we consider s1, then s1 is nothing but the value of s, but in which the point x1 y1 is substituted in place of x and y. Okay, so wherever we have x and y terms, we merely replace them with the x and y coordinates of the external point P. Okay, remember the point is external to the parabola, it's not lying on the parabola. So therefore clearly S1 would correspond to the expression y1 square minus 4ax1. Alright, and lastly t square, where t stands for the expression on the left hand side of the equation of the tangent to the given parabola. And we have seen how to get the equation of the tangent in case of the standard parabola, that is y1 minus 2a into bracket x plus x1 equal to 0. So therefore the left hand side portion is denoted by the symbol t, and we have to write the t square. Alright, so once we get the expressions of s, s1 and t, we have to substitute them in this standard formula and then simplify, which gives us the joint equation of the pair of tangents as required. Let us solve one question based on this so that these symbols will be clear. Find the joint equation of pair of tangents to parabola y square equal to 8x from the point minus 2, minus 3. Now first of all let us write the equation of the parabola in standard form, that is 4ax, so that we can write as 4 into 2 into x, that is 8. So clearly here a is nothing but 2, so we have that piece of information with us ready. Now let us write down the expressions for s, s1 and t, which is what we need. Now s stands for the equation of the parabola in the form in which all terms are on one side and 0 on the other side. So equation of the parabola is y square equal to 8x. So therefore clearly y stands for y square minus 8x. Okay? Of course that is equal to 0. That is the equation of parabola. Now s1 will stand for y1 square minus 8x1. Now since we know what is x1 and y1, it is given to us, that is minus 2 and minus 3. So therefore we write that as minus 3 the whole square, that is 9, minus 8 into x1 is minus 2, so that gives us 25. So basically the S1 will indicate some numerical value because it has all the coordinates and constant terms, right, and no variable term. And lastly we have t, right, that stands for y1 minus 2a into bracket x plus x1 in the original form. So therefore now here by substituting we get minus 3y minus 2 into a itself is 2, so therefore here we get minus 4, and x minus x1 is minus 2. So on simplifying we will get this as minus 4x minus 3y plus 8. So that's the expression for t. Right? Now joint equation of the pair of tangents is given as ss1 is equal to t square. So let us substitute all the expressions. S stands for y square minus 8x into s1 stands for 25 and t stands for minus 4x minus 3y plus 8 the whole square. So therefore on simplifying this equation we will finally get the joint equation of the pair of tangents in the most simplified form.